All right, for Algebra 2, we're doing 2.7 today, the distances and midpoints. All right, so we are going to, our objectives are to derive the distance and midpoint formulas. I'm actually going to give those to you, maybe explain why, or show where they kind of come from, but I'm going to give them to you. We're not going to have to derive them. We're going to find distances and midpoints by applying the appropriate formula and graph an ordered triple as a point in space, and just kind of use these ordered triples. It's a new concept. So to get us started, when we are given 2 points, okay, you can draw a right triangle and use the Pythagorean theorem to find the distance between the points. Okay, so we have our 2 points here. So let's see, point 1 and point 2. Yeah, sorry. So we have our 2 points here. And so this is where we draw in our Pythagorean theorem, right? We have our legs. Okay, so our horizontal leg, or A down here, is going to equal, the distance is the absolute value of x sub 2 minus x sub 1. And our vertical leg, or B over here, its distance is the absolute value of y sub 2 point minus the y sub 1 point. So if we subtract our y's from our two different points. Okay, and the thing about this, okay, is if we take that a little further, then we can use those, right? We can put them in the Pythagorean theorem, that a squared plus b squared equals c squared. So we can put those in that formula and find our length c here of our hypotenuse. So some pretty awesome stuff in that case. So our distance formula, that's what gets us to our distance formula. The distance d between any 2 points. Okay, so p sub 1 and p sub 2. Our p sub 1 point is going to be x sub 1, comma y sub 1, right? That's our point 1 coordinates, and our point 2 sub 2 coordinates are x sub 2, comma y sub 2. So those are the coordinates from our second point. Okay, it's given by this formula. So d, remember, equals distance equals the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. And it says distance, but don't forget, like, distance is the same thing as length. A lot of times when we're reading these problems, it says find the distance between these 2 points or the length of these 2 points. It's still the distance formula. Okay, if you are finding a length or a distance, it is the distance formula. All right, so let's put this into action with example 1. In example 1, we need to find the distance between -4, 2 and 1, 7. Okay, I've given you the distance formula. So this is going to be our point 1, so p sub 1, and this is our point 2, or p sub 2. So our distance is going to equal the square root, our x2 value, and our x1 values. So we're going to do x2 is 1, so 1 minus -4 squared plus our y values. Okay, so we've got 2 and 7. We do y2 first. We did just like we did number 1 first. From our second point, we're going to do 7 minus 2 squared. Okay, so this is going to equal the square root. 1 minus -4, we're going to change to plus a positive. So this is 5 squared plus 7 minus 2 is 5 squared. So this equals 25 plus 25, which is the square root of 50. Okay, and you have a couple different options there. So our distance equals the square root of 50. All right, so this can be simplified. A couple things you could do. One, if I say it's okay to put it in your calculator, you could put it in your calculator and get me a decimal. So it's about 7.07. Okay, it's approximately that. You can take 50 and see if there are any, like, do radical simplification, right? So 50 is equivalent, okay, think about if you do prime factorization. So we can do 50 divided by 10, and that or 50 divided by 5, pardon me, is 10. Divided by 5 again is 2. So all of these numbers, I divided by a prime number here, divided by a prime number 5 here, and I ended with a prime number. So I've factored it. Okay, so then this would say this is equal to 5 squared times 2, the square root of 5 squared times 2. Because we have a 5 squared, we could say this is 5 times the square root of 2 as well. So at this point in time, I would take either of those. Okay, there's 3 different options for how you could give me the answer. Okay, so next up, we have the midpoint of the segment that connects our P sub 1, so our first point, and our P sub 2, our second point, is here. M, notice the midpoint. There's no equal sign, nothing else. Like this is actually going to give you the coordinates of the midpoint. So we add our x values from our 2 points, divide them by 2. That's going to give us our x coordinate. Okay, so this is like x of the midpoint. Comma, we add our y values together and divide by 2, and that's going to give the y value of the midpoint. Let me make that a capital M. Okay, so that's what this formula is doing. It's literally giving you the x coordinate of the midpoint and the y coordinate of the midpoint. Super nice. So let's give that a go in example 2. I'm going to go ahead and move up first though. Okay, so find the midpoint of the segment with endpoints -3, 4 and 1, 9. Okay, so again, we have 2 points, P1 and P2. So our midpoint is going to be our x1 plus our x2. So -3 plus 1. I apologize for that. I didn't silence my phone before I started. Okay, so -3 plus 1 divided by 2. Those are our x values, comma. And now we're ready for our y values. We're going to have 4 plus 9 divided by 2. Okay, so you're literally, this is finding the median. If you remember back to like middle school math, right? To find the middle or the median, you add the numbers, and you divide by how many numbers you have. Okay, well, we have 2 points, and we divide by those. So pretty good stuff there. All right, so let's go on. So our x coordinate, -3 plus 1 is going to be -2 over 2. Our y coordinate, we have 4 plus 9. That's going to give us 13 over 2. Okay, we keep going so we can simplify. -2 divided by 2 is -1. 13 divided by 2 is 6.5. So our midpoint, M, is, the coordinate is at -1, 6.5 to graph that. Pretty good stuff, right? You'll get to use this a lot. All right, example 3 says write the slope-intercept form of the equation of the perpendicular bisector of the segment in example 2. Okay, so we want to write the slope-intercept form of the equation of the perpendicular bisector of the segment in example 2. Okay, so in example 2, we had the segment that we had, okay, was, or the numbers that we had were -3, 4 was 1 point, and 1, 9. Okay. And we could even graph those to help us out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And -3, 4. 1, 2, 3. 1, 2, 3, 4. And we can graph the segment. Okay. So write the slope-intercept form of the equation of the perpendicular bisector of this segment. Okay. Well, first of all, in order to do this, we need to find the slope, right? What does our slope equal? Okay, well, recall our slope is the rise over the run. So to get from this point to this point, or vice versa, what do? So we go up 1, 2, 3, 4, 5. So we went up 5, And then how many do we go over? 1, 2, 3, 4. It's hard to see on my graph a little bit, but we went over 4. So my slope, m equals, I went up 5, so that's positive for my rise. And my run is to the right, so that's also positive. So my slope is 5/4. Okay, now though, we want the perpendicular bisector. What do you remember about the slopes of parallel and perpendicular lines? Okay, parallel lines have the same slope. Perpendicular lines have the opposite reciprocal. So we're going to take this and say, all right, well, the slope of our perpendicular line, this is the symbol for perpendicular, needs to be the opposite of this one. So if this is positive 5/4, we need a negative. Good. And we need the reciprocal. If this is 5/4, our reciprocal is perfect, 4/5. Okay, so the slope of our perpendicular line is negative 4/5. All right, so now we want the perpendicular bisector of this line. In order to have that, we need to know where the middle is, right? We need to know where our midpoint is to put that in there. But we already found our midpoint, didn't we? Yeah, that was example 2. Okay, so the midpoint of this pair was -1, 6.5. So at -1, 1, 2, 3, 4, 5, 6, 6.5, something like that, okay, is our midpoint. And that's where we want our perpendicular bisector to come through. We want it to come through the middle, like right through the midpoint and at a 90-degree angle. So here's the thing. We need to take our midpoint and our slope of our perpendicular line, and we need to put them in that point slope form. Again, we're training your brain today. That point slope form, if you recall, is y minus y1 equals m times the quantity x minus x1. So y minus, our y value is 6.5, equals our slope, negative 4/5, times our x minus our x1 value, which is here, which is -1. All right, so then we have y minus 6.5 equals negative 4/5 x, because we're distributing. Minus a negative, we're going to change that to plus a positive. And now we're going to distribute. Negative 4/5 times 1 gives us a negative 4/5. Okay, we got to get y by itself for slope-intercept form. So we're going to add 6.5. Or we might want to say, well, we'll leave it there. Y equals negative 4/5 x. Let's say we want this in fifths, so we can add it. Or 4/5 would be, 4/5 would equal 0.8, negative 0.8, if we want to convert to decimal form. So negative 0.8 plus 6.5 will give us a positive 5.7. So not the nicest equation, but you're in Algebra 2 now, not Algebra 1. So you get ugly equations sometimes. Okay, so lots of work for that one, right? In order to get there, but we need to think through how we're going to make it to that place. And that'll help tremendously to take the time to think through and understand the question. All right, our points in space then. Getting into some craziness. All right, so points in space. Notice my little space stars out there. You can designate a point in space with an ordered triple. Okay, so the point, this is called an ordered triple. The point is x, y, z. So now we don't have, it's more of a three-dimensional plane. And you can look at that here. Okay, we've got this three-dimensional. Notice the change in your axes. Okay, the axis here is your x that kind of comes out at you. Okay, that's your x-axis. Then suddenly your y-axis is the one that's horizontal. Okay, it's kind of real crazy here. That's what I'm saying. And then z is your vertical axis now. So things are really kind of changing. Okay, it's also kind of cool if you think about this box here in this way. Okay, so if we have this, says it's like our P1 back here. Okay, so our first point is there. And so we have some different, we can see this shape in more of a three-dimensional way here. And so each side of the triangle provides us with an x, a y, and a z to get our point back there. All right, so the cool thing about this is that you can determine the distance between 2 points in space as well as the midpoint between the 2 points just using a variation of the distance and midpoint formulas. So notice all we're doing is to the distance formula, we're adding, we're squaring the quantity of the difference of the point z points. And for the midpoint, we're doing the sum of our z's and dividing them by 2. Okay, because there's 2 points we're finding the midpoint between. So it's pretty awesome stuff. In the past, we've tried to graph them. Last year, it was kind of a train wreck. So we're not really going to worry about that. And it was more just for fun anyway last year. So maybe on a fun day we will. But let's get into this then, this variation, example 4. Let's find the length and midpoint of the segment with endpoints 2, -1, 3, and 3, 5, -1. All right, so first up is our distance. Our distance is going to equal the absolute value of the differences of their points. So I've got 2 and 3. Okay, so it says x of 2 minus x of 1. It honestly doesn't matter which way you do them, but I'm going to do them in that order. So 3 minus 2 squared. All right, plus my y. So I'm going to circle my second one first. 5 and -1. So the quantity 5 minus -1 squared plus, now I'm ready for my z's. -1 and 3. -1 minus 3 squared. Okay, so the key, right, is we have to keep the same order. So we did 3 minus 2, 5 minus -1, -1 minus 3. They always have to stay the same order in order for our formula to be correct. So this is going to equal the square root of 3 minus 2 is 1 squared. All right, plus 5 minus -1, we'll change that to plus a positive. So that's 6 squared. Plus -1 minus 3 is -4. So -4 squared. Okay, I'm putting my -4 in the parentheses so I remember the whole thing is squared. So this equals the square root of 1 squared is 1, plus 6 squared is 36, plus -4 squared is 16. Because remember, -4 times -4 is a positive 16. All right, so this equals the square root. 1 plus 36 is 37, and 37 plus 16 is 53. I made my absolute value sign, or my square root sign, a little long right there. Okay, so my distance equals the square root of 53. Or again, if you put it in your calculator, you're going to get that it's approximately 7.28. I was trying to write my 2 first here. It's approximately 7.28. And 53 is a prime number, so I can't simplify that radical. I could only leave it as the square root of 53, or 7.28. All right, that is it for your lesson today. So, good night. or have a great day, and I'll see you tomorrow.